This lesson, we're just going to look at practicing some identities. So we're just going to practice doing some of these identities and proofs. Some of these will involve using double angle and sum and difference angle identities, but really we're focusing on proofs. So for this one here, we want to prove that cosecant of x plus pi is equal to negative secant of x minus pi over 2. Okay, well, this is a sum and difference identity, right? We could apply some geometry, but we're going to do an algebraic proof, so we really need to use a formula, but we don't have formulas for cosecant and secant. So we need to really write this in terms of the sine and cosine. So this becomes negative 1 over cosine of x minus pi over 2. Okay. This one here, we're going to use an identity, but if we think of what's happening here, if I think of sine x, where sine x is in quadrant 1, and I rotate it 180 degrees, my vertical position is just going to be negative. So we should end up with negative sine x here. So that's what I'm going to do. I'm going to apply identity. So it's sine x cosine pi plus sine pi cosine x. Okay, so there's my sum identity. And using that sum identity, it is going to simplify to negative sine. Because that's equal to 0, that's equal to negative 1. So I end up with negative sine x. Okay, well, I kind of knew that when I did this here, because I'm basically going to the other side of the circle. Sine is vertical, well, the vertical is going to be opposite. Okay, it's going to be negative of whatever we started with. On this side here, I'm going to apply the sum identity for cos, so it's cos cos. So it's minus, so it's going to do plus sine sine. Okay, so the cosine of 90 degrees is 0. So what we're going to be left with there is negative 1 over 0 plus sine of pi over 2 is 1. So we're going to end up with sine of x in the bottom. So there it is, left side equals right side. There, we've proven it. All right, for this next one here, we've got a binomial fraction here. We've got a monomial term that's not in fraction form. So the strategy I'm going to use, well, I want to put it into fraction. I'm going to put a common denominator, make this into one fraction, and see how it compares. So that's going to be the start. I have no idea what this is going to look like, but I know that's a strategy. At least I can work with that strategy. Okay, so I'm going to do this. I'm going to end up with cos x minus 1 plus sine x tan x. And that's all over tan x cos x minus 1. Okay, so just straighten that out a little bit. Where am I at? Okay, well, it doesn't look like I've gotten really too far with this, but I do know that tan x has a sine x in the numerator, so that seems to match. So I think I might start there. I might convert those tans to sine and cos. Okay, so I'm going to do this. Cos x minus 1 plus sine x times sine x over cos x. Okay, and then I'm going to end up with sine x over cos x, and that's cos x minus 1. Now I'm going to keep this factor, although it seems to generate a sine x here, it's going to generate a binomial term. I don't really want a binomial term here. If I want to make these match, it's better to introduce that cos x minus 1 as a factor down here. Okay, so I'm just going to clean that up a little bit. I'm going to multiply top and bottom by cos to get rid of that cos. And that's going to get rid of this cos as well. So I'll show you what I'm going to do algebraically. I'm just going to multiply the top by cos x and the bottom by cos x. Okay, in doing so, I end up with cos squared x minus cos x plus sine times sine is sine squared. Okay, and that gets rid of the cos on the bottom there. Okay, so denominator cos times sine over cos, the cos disappears. So I'm just left with cos x minus 1. Okay, well, where am I going here? Well, it seems to be getting a little bit closer. I've got my sine x that matches, so I'm just going to make a note of that. I don't want to mess with that because that already matches. I'm not going to touch that. Okay, once it matches, no reason to mess around with it. Here I get cos squared plus sine squared. Really, that's 1. And so I'm going to end up with 1 minus cos x. Oh, well, this works out nicely because I have a cos minus 1, which is the opposite. So I'm just going to flip that around, and I'm going to end up with my negative, and the cos x minus 1s will cancel out. And there's my proof. Okay, those cancel out. Make sure you show the last step there, negative 1 over sine x equals right-hand side. So there's my proof. Okay.